Introduction to calculating the curl of a vector function. So basically, when you're calculating the curl, you are creating another vector function. It's represented by some arrows or the vectors on the vector field. We introduce the vector differential operator del or nabla as nabla is basically the partial derivative with respect to x in the direction of x-axis plus partial derivative with respect to y in the direction of y-axis plus partial derivative with respect to z in the direction of z-axis. You can switch this around. You can write it as partial derivative with respect to x times I plus partial derivative with respect to y times j plus partial derivative with respect to z times k. And if you have a vector field like f with scalar functions p, q, and r, then the cross product between the nabla and the vector field f, as you remember from elementary calculus talking about cross product between two vectors, is the determinant. You're going to list ijk showing the direction in the direction of x-axis, in the direction of y-axis, and in the direction of z-axis. On the second row, you're going to list all the elements or components of nabla, which is partial derivatives with respect to x, with respect to y, with respect to z. And finally, on the last row, you're going to list the elements or components of the vector field f, p, q, r. Remember that when you're calculating the determinant of a 3x3 matrix, you're starting by the very first element, the entry A, and you multiply that by the determinant of this 2x2 matrix minus B times the determinant of the first column and the third column, or this 2x2 matrix, dg, fi, and finally, your last entry is C plus C times the determinant of this 2x2 matrix, dE, gh. So that's how we calculate the determinant of this 3x3 matrix, or the determinant of this 3x3 matrix, which is our curl. So the curl is equal to I times the partial derivative of r with respect to y minus the partial derivative of q with respect to z. So again, here you have your I, and you look at the determinant of this 2x2 matrix, which is the partial derivative of r with respect to y minus the partial derivative of q with respect to z plus j, and then I distributed the negative sign, the partial derivative of p with respect to z minus the partial derivative of r with respect to x plus k, which is multiplied by the partial derivative of q with respect to x minus partial derivative of p with respect to y. Again, following the formula, you have a formula for the curl of the vector field f. And as you can see, you have the first component, the second component, and the third component for this vector. So curl of f, as we mentioned before, is also a vector. Let's take a look at one example here. Here we have the vector field f, xz, in the direction of x-axis plus xyz in the direction of y-axis minus y squared in the direction of z-axis. And we're interested in finding another vector field out of it, which we call the curl of f. Remember that curl of f is equal to nabla cross f, which is the determinant of this 3x3 matrix. On the first row, you're going to list I, j, k, showing the direction. On the second row, you're going to list the elements of nabla, which are partial derivative with respect to x, with respect to y, with respect to z. And on the last row, you're going to list the component of the vector field, xz, xyz, and negative y squared. Following the determinant of 3 by 3 matrix, it is equal to partial derivative of negative y squared with respect to y minus partial derivative of xyz with respect to z in the direction of x minus, then you're going to have the partial derivative of x with respect to negative y squared minus the partial derivative of z with partial derivative of xz with respect to z in the direction of y-axis. And finally, the last component is the partial derivative of xyz with respect to x minus the partial derivative of xz with respect to y in the direction of z-axis. Very good. But this is equal to the partial derivative of negative y squared with respect to y is negative 2y minus the partial derivative of xyz with respect to z is xy. You're going to add I, showing the direction of x-axis, minus. Now, the partial derivative of negative y squared with respect to x, this guy doesn't have any x in it, becomes 0, minus the partial derivative of xz with respect to z, which is x, and then in the direction of y-axis, plus, well, partial derivative of xyz with respect to x is yz, minus the partial derivative of xz with respect to y. This guy doesn't have any y in it, so it becomes 0 in the direction of z-axis. So let us simplify this. You get negative y times 2 plus x in the direction of x-axis plus x in the direction of y-axis, and then finally you have yz in the direction of z-axis. So this is the curl of this vector field. We can visualize this vector field as well. For simplicity, you can just set values here and then use a 3D grapher for vector field and visualize this guy, which shows a vector field relevant to this larger vector field that you have here.